In a prior episode, we covered the Event Handler app class, which is becoming a very common pattern. Now, here's what I like about that pattern. It's unit testing. Code bundled in a component event may only be tested through the component, so we can't test discrete code fragments. For example, we can't test just a field change, but with a properly written app class, we can test just a fragment, just the one event handling method. We don't have to create a component interface or load the component online. We can just test the one discrete method. But a question though, how? How would you invoke that one discrete method? In our 2-day app class course, we share a couple of options. I mean, testing could be as simple as invoking an app class from, say, PeopleCode and App Engine step. But in this episode, let's use PSUnit, a PeopleCode unit test framework similar to other test-driven development frameworks. Now, PSUnit started as an internal Oracle Skunkworks project, and it made its way into the community in 2009. Now, you can still find the PeopleTools blog post and documentation on Oracle's site, but the related App Designer project is no longer available for download. Now, it is still available, though, because it's included with the Campus Solutions PUM image, and my friend Cash has a copy in his GitHub repo. We'll include a link to the repo and the documentation in the video description. So here, I have an idea. Let's take the Event Handler app class we started in a prior episode and write a PSUnit test case. So let's review our scenario. In our course sessions, we have this prerequisite checkbox. Now, when that prerequisite checkbox is checked, then the prerequisite code should be enabled. Otherwise, it should be disabled. And we already have an app class handler and method, but no implementation details. Let's use tests to drive our code implementation. Now, the idea behind test-driven development, sometimes called test-first programming, is to create a test before writing code. Now, there are many reasons to write tests first. One reason is to ensure we understand the requirements. Another reason is to avoid confirmation bias. In other words, we write tests based on specs rather than tests based on code. So let's write a test case for this method. Now, all tests start with the same boilerplate template. So let's copy a template from the documentation. From the PeopleTools blog post, we can find the documentation link. And then in here, we can find a code listing. Now, this code listing isn't per se a template. In fact, it's a specific implementation. But we can copy it, and then in Application Designer, we can create an application class for it. Now, at this point, though, we have a decision to make. Should we put tests in a separate top-level package, or should we make them a sub-package of the main package of the system under test? I mean, you know, I kind of like the relationship and the organization and association of having everything all under one roof, so to speak. So here's what I'm going to do. And by the way, I'm open to suggestions on that. You know, let me know what you think. Should tests go in their own package, or should they be in a sub-package of the system under test? Here's what we're going to do. I'm going to create a sub-package. Let's name it tests. And then inside here, let's create a class that has a name similar to the system under test, but with the prefix of test, trn, crse, ses, event handler. Save. Okay, and now let's paste in. Let's make sure we have it copied. Let's paste in our code template. Now the code template, it came from an implementation. So we have some strings we need to replace. Like, for example, the class name itself is wrong. We can look up here and see the class name. Let's use a string replacement for that. How about replacing with what we see in the header up here? Test, trn, crse, ses. Fix our typos. Event handler. Nothing like doing a find and replace with the wrong string. Test, trn, crse, ses, event handler. Great. Replace all. Okay, and let's see. There are some implementation specific details here. Let's comment those out. We'll use them in a minute. We can refer back to them. Let's just make sure our code compiles first. Oh, no, see, we imported I still have the wrong import here. This is from the sample. Let's replace this with our system under test. Okay, perfect. I'm just going to try to save this time. Perfect, that looks great. Okay, now let's implement a test. What we're testing is a method designed around the component buffer. In order to run this test outside of the component buffer, I need to create a mock component buffer, and my method needs to accept that mock component buffer coming in as a parameter rather than being context aware, context sensitive. It can't just, for example, invoke get row set, because in this case, it would be running in the context of the wrong component. So let's go ahead and create that mock version of the buffer. So we have to ask ourselves, as we're creating the component buffer, how much of the component buffer do we want to create? I mean, here in this case, I want to create just enough for context. What is the context? Well, it's when somebody clicks, here, let's take a look at the page. It's when somebody clicks or activates, enables that, changes the value of that checkbox. So let's see, and then we're going to be changing the value or the enabled property of this field. So we know that we have two fields we're going to be interacting with on field change, and both of those fields belong to the same record. So let's make record our context. Local record in session, because that's what we're working with here is sessions, equals create record, and we'll drag and drop to avoid typos. Looks good. Let's save just to make sure. Save early, save often. You know the mantra. And then let's see. On our session, we need to emulate, pretend like we're checking the box. And I don't want to mistype that field. It's kind of has a long name. So again, let's use drag and drop. That value equals y. Okay, so that's emulating checking. Okay, now we need to evaluate the response that came back, right? Did the prerequisite course code, is its enabled property set to enabled or disabled? Is it true or false? And for that, we can use the PSUnit assertions. There's several different assertions: assert strings equal, assert dates equal. In this case, all we have to do is just use the method named assert. Here, we can drill into the source here. Actually, let's comment this out first, and then drill into the assert. And we can see assert, a method called just assert. Assert is true. So we'll pass in there is the property, the enabled property. It has a true false, so that's exactly what we're looking for here. Okay, assert in session prerequisite course code dot enabled. And we need to give back, or what, the additional parameter. In the event of a failure, we need to tell PSUnit what to print to the log. So let's print checkbox was checked, but course code is not enabled. Okay. That looks good. Okay, but wait, in the middle here, we actually have to invoke the method, don't we? The field change method. So right there, that's emulating the field change. Now let's invoke the field change. For our field change, we need to have an instance of our system under test. So local, what's the name of this class up here? trn crse ses event handler, and let's just call it target, or system under test, or some people like to abbreviate it as SUT, system under test, equals create trn crse ses event handler. Okay, and we also need to import this. Actually, we already did, didn't we? Perfect. Okay, great. We have it created, and now let's invoke the method. Oh, too many semicolons there. I just don't happen to have that method name memorized. So let's go back and look at the source, grab the method name, and then back to our test case. Oh, it has to come after we've emulated checking the box, setting it to Y. Okay, this is what we want to invoke, right? Prerequisite field change. Oh, sorry. Ampersand SUT dot. Perfect. Okay, I like that. One problem though. See, we have our component buffer context that we need to pass into the method. So by creating this test case first, we discovered something. We discovered that we need a parameter. We need to be able to pass information in. So now that we have that knowledge, now that we've discovered that, we can return back to the original and create a parameter here. Oh, I like that. That's perfect. And then back here, pass in that context. That's great. Okay, let's test this now. So online, in a new window, I'm going to navigate to PSUnit. PSUnit, once you have it installed, sits right on the root of your PeopleSoft menu. And what we need to do is create a new test case. So let's call this one, let's call it, well, the name of the component, TRN, CRSE, SES. That sounds like a great name. And choose add. And then we need to insert some tests. So our package root is named TRN. And the path is tests. And the class name happens to be the only test in there right now. Let's save this and let's run it. Oh, select a test, of course, and then run it. Hey, look at that. It passed. What? Wait. It passed? Really? Here's why I'm so surprised. Here's why I'm so surprised it passed. We haven't written any code. Oh, close that. We haven't written any code yet. How can it pass? I'll tell you how it passes. The default value for enabled is true. So basically what it's saying is, hey, it is true. This is why we write our tests before we write our code, is to ensure that our tests actually work. See, in this case, we've tested, it passed the test, but it shouldn't have really passed the test, should it? I mean, I don't know. Yes, of course it should have, thinking about it logically, because that's the default value. But then again, is our test really testing anything at this point then? No, it's not, is it? Which tells us we need to go back and refactor our test. So here, let's do this. Let's try this again, but this time with an N. And instead of assert, let's go back and let's look at the test base. Let's see what kind of methods we have in here. So let's see, we have assert strings equal, assert strings different. So you can see assert strings equal and assert strings differ. So we have an assert. Now we don't have an assert not, but hey, that's pretty easy, isn't it? We can do it this way, or this way, right? That would be the same as not. Or what if we did, we could do that as well. I mean, there are a couple different ways. The end result is we just have to have a true false value there for the evaluation. So either way, whatever works best for you, whatever communicates most effectively to you and your team, that's what you should choose. Is it the word not, or is it equals false? Okay, here, let's see. Let's change this to checkbox was deselected, but course code is enabled. Okay, let's run the test again. Let's see what happens. Perfect, it failed. Yes, you ever been excited about a failure before? I am, right here, I'm excited. It failed. Now look at that. We have a very dramatic red color there, not the anticlimactic white that we see when on a pass. Instead, we see a very bright, vibrant red. Failed. Awesome. I like that. Okay, good. Now we know our test is working well. Okay, now let's take this example here, this scenario here. I like it. It's working well for me because we have a test that's failing. So now that we have a test that's failing, we write the code to pass. That's the way that test-driven development is designed to work. So back here on our application class itself, receiving a session. Let's see, this is the prerequisite course code. .enabled equals false. That should pass the test, right? Oh, sorry. Drag and drop, got an extra record in there. Okay, let's find out. I mean, that'll pass the test that just failed. If we look here, we see that it specifically says checkbox was deselected, but course code is enabled. Okay, that gives us an idea. That tells us where to start, where the error happened, which test failed. This is kind of a composite test, isn't it? It's a test of the one method. It's testing multiple or having multiple assertions within one method. Is that a good practice? I don't know. I'm going to leave that one up to you. Let me know. Write something in the comments. Let me know what you think about that. Multiple assertions in one test case. Let me know what you think about that. Okay, so the one that passed, I don't know. The one that failed, we're going to make it pass. Oh, but it still fails. Why? Oh, because now we have the alternate problem, the opposite problem. Checkbox was checked, but course code is not enabled. Awesome. Hey, at this point, our whole goal is to test our test and make sure our test works properly. That's why we hard-coded a value there in the implementation. That's why we've written a couple of different assertions in our test. We want to make sure, is our test case working properly? Once we know our test case is working properly, we can go back and refactor to create a proper implementation. Okay, so here's what we know. We need to evaluate the prerequisite check. So let's do this. Prerequisite check. Now again, remember, we want to avoid context awareness because the component where this is actually running doesn't have trn, CRE, SE, SES. So we need to grab that from the parameter that came into the method. This is what we're evaluating, enabled. It's enabled when prerequisite check value equals Y. Otherwise, it should be false. Oh, sorry, typo. Awesome. Okay, let's run it again. Woohoo, success, it passed, didn't it? Now, I know we talked about this in a prior session as well. This right here, I love it. One-liner, simple, to the point. What do we say? That Spartan. That's the term that we use for that. Spartan, minimalistic programming. But I don't know. Maybe sometimes we take that Spartan a little bit too far. Here, let's do this. Local equals. Let's use a placeholder, a variable, to provide meaning to this expression. Instead of a multi-expression statement, as we had multiple expressions in one statement, let's break it up a little bit just for other people, just to make it easier for them to read. All right, let's test, make sure it still passes. Awesome, it still passes. Great. Now, of course, the next phase would be to plug this into our component and then test it out in real life with our component as well. I have one critical requirement for a well-written event handler. Avoid context awareness. In other words, we can't use getRowSet or other context and component-specific functions, or even variables for that matter, such as %component, because %component and %page assume an online context. What if, say, we wanted to figure out a way to run these test cases in batch, such as an app engine? We wouldn't have our component buffer as context, and we wouldn't have the component variables available either. Now, the great thing about PSUnit is it forces us to write our code in a context-agnostic manner. As we saw here, it's not possible to reference the target component from the PSUnit component buffer. But tell me, what are your experiences? Does a tool like PSUnit help you write better modular code that is easier to read? Or are we just adding complexity? Now, the concept for the soundbite was adapted from our Application Packages 2-day course. Are you interested in learning more? Check out our website to see our latest offerings. Or here's an idea. Subscribe to our LinkedIn, Facebook, and Twitter feeds to receive updates every time we post a course. Or even better, give us a call and let us help you develop a training plan. Now, if you enjoyed this episode, be sure to like, share, comment, and subscribe for more content. And we look forward to seeing you in the next episode.